in example 5, we have to determine the equation of a quadratic function whose graph is given. Find the x-intercepts. Well, the graph doesn't cross at a whole number, does it? I mean, here, this x-intercept's between 0 and -1, and this one's between 2 and 3, okay? All right, so we have to glean what information we can from this graph and determine what the equation of the quadratic function is. Well, one piece of information we have is that the vertex is located at the point -3, 1, right? This point here is across from excuse me, the vertex is the point 1, -3, right? It's below x equals 1, and it's across from y equals -3. So we deduce that 1 -3, right, is the location of the vertex. Right? 1 is the x-coordinate, -3 is the y-coordinate. And then we can also deduce that the y-intercept is at y equals -1. So that's the point 0, -1. So that's everything we need to come up with the quadratic equation for this parabola. Okay. So in standard form, we have y is equal to a times x minus h squared plus k. H is the x-coordinate of the vertex, and k is the y-coordinate, right? So h is equal to 1, and k is equal to -3. So we put in 1 for h and -3 for k, and we have y is equal to a times x minus 1 squared minus 3. So now we just got to figure out what a is. To do that, we use the y-intercept. X equals 0, y equals -1. So we plug in for x and y and solve for a. So put a -1 in for y. Put in 0 in for x. Solve for a. So we're using the point 0, -1. Where 0 is the x-coordinate, and -1 is the y-coordinate. Okay? Now you got to solve for a. So -1 is equal to, well, 0 minus 1 is -1, -1 squared is +1, and a times 1 is just a. So a minus 1 is equal to a minus 3. Then we add 3 to both sides. We get 2 is equal to a, or a is equal to 2. And so now we replace a over here with 2. Y is equal to 2 times x minus 1 squared minus 3. So that is the equation for that parabola in standard form. You gotta find the x-intercepts. How do you find the x-intercepts? Set y equal to 0 and solve for x, right? So we have 0 is equal to 2 times x minus 1 squared minus 3. So we add 3 to both sides. And 3 is equal to 2 times x minus 1 squared. Now we divide both sides by 2. We get 3 halves is equal to x minus 1 squared. And now I like x on the left hand side, so I'm going to flip the two sides. And now, what does squaring? Square root, right? I'm going to use square root method. So take the square root of the left hand side. And take the square root of the right hand side. What am I missing? Use square root method. What do you got to put on the right hand side?
Plus or minus.
Plus or minus. There are two solutions. So we have x minus 1 is equal to plus or minus the square root of 3 halves. So make sure the 2 is under the radical. Students have sometimes just not going down that far. Now we add 1 to both sides, right? And we'll put the 1 in front of the plus or minus. And x is equal to 1 plus or minus the square root of 3 halves. Now we could rationalize the denominator and all that, but I don't think it's necessary in this case. So those are the two x-intercepts. X equals 1 plus the square root of 3 halves, and x equals 1 minus the square root of 3 halves. And that makes sense, okay? Because 3 halves is between 1 and 2, and the square root of 3 halves is going to be between 1 and 2. And the number between 1 and 2 added to 1 is greater than 2, but less than 3. And we see that the graph crosses the x-axis between 2 and 3. Likewise, for the minus. Square root of 3 halves, right, is between 1 and 2. So the square root is between 1 and 2. 1 minus 1 is 0. 1 minus 2 is negative 1. And we can see that the other x-intercepts between 0 and minus 1. Okay. So these numbers make sense. Okay. Any questions on that? Okay. All right, flip over your page. In example 5, we're going to graph the quadratic function f of x equals minus x squared plus 3x plus 4. Determine the domain and range, the vertex, the axis of symmetry, x and y intercepts. Determine whether the function is increasing or where it's decreasing. Okay. So we're doing a lot with this problem. Riddle me this, ladies and gentlemen. Is the graph going to be a parabola? Yeah. Open up or open down? Down, right? I mean, it's good to know this kind of things in advance, right? You know that the graph, wherever it is in a coordinate plane, is going to open down. Why? Because the number in front of the x squared is negative. Okay? Alright, so a in this case is equal to -1, b is equal to 3, c is equal to 4. Okay? Now, to find the vertex, we have two techniques, two ways of finding the vertex, right? One is complete the square, and the other is, and this is what works for me, is what's the formula for the x coordinate of the vertex from A, B, and C? Remember? First thing we did, like on page 1 of your notes. The x coordinate is the -b over 2a, right? So you can either complete the square to find the vertex, okay? Miss in the back, you gotta be over your notes. You can either complete the square, or you can remember the x coordinate is -b over 2a. Okay? So that's the way I did it. Okay? So b in this case is 3. So we have -3. And then 2 times a is 2 times -1. So we have -3 over -2. Negative over negative is positive. And so the x coordinate for the vertex is 3/2. So I can put x, I put x out here in front of -b over 2x. It's also called h, if you write it in standard form. The y coordinate is f of -b over 2a. Well, -b over 2a is 3/2, so we got to find f of 3/2, right, for the y coordinate. How do we find f of 3/2? Put 3/2 in for x up here, right? So you have to decide what's easier for you to do, this way or complete the square. Okay. So f of 3/2 is equal to the negative 3/2 squared plus 3 times 3/2 plus 4. And now it's PEMDAS working with fractions. Okay. 3/2 squared, 3 cubed over 2, 3 squared over 2 squared is 9/4. So we have minus 9/4. Then 3 times 3/2, 3 times 3 is 9, so we have 9/2 plus 4. Now you need common denominator, right? What's the common denominator? 4, right? Top and bottom by 2. So we have the y coordinate for the vertex is equal to minus 9/4 plus 18/4 plus 16/4. 16 divided by 4 is 4. When you multiply top and bottom of 9/2 by 2, you get 18/4. And now you combine, and you get what? 9 plus 6, 25/4. So the y coordinate for the vertex is 25/4. So the vertex is at the point 3/2, 25/4. Okay? Any questions on that? What's the axis of symmetry? Yeah. Axis of symmetry is a what? What is it?
Imaginary line that crosses through
I wouldn't call it an imaginary line, I would call it a vertical line, right? That goes through the vertex. And the equation for that vertical line is x equals 3/2, right? You set x equal to whatever the x coordinate is. So that is the axis of symmetry. Remember, it's a vertical line. Y-intercept. What's the y-intercept? Can you get it by inspection? 4, right? To get the y-intercept, you set x equal to 0, and you just end up with the constant term, right? Y equals 4. So the y-intercept remind you, right? Replace f of x with y, and then put 0 on for x. You have minus 0 squared plus 3 times 0 plus 4, or y is equal to 4. It's just a constant term when the function's written in ax squared plus bx plus c form. Or the 0.04. That's the y-intercept, okay? Now the x-intercepts are not so easy. To get the x-intercepts, you set the left-hand side here equal to 0, right, and then solve for x. So we have 0 is equal to minus x squared plus 3x plus 4. And again, I like x on the left-hand side, so I'm going to switch the two sides. And now you got to factor this. But I hate factoring when the number in front of the x squared is negative. Now, if you can factor this, go for it. But I like the number in front of the x squared to be positive like that. So I got to divide both sides by -1. And you know, when you divide by -1, it changes the sign of each of those terms. So I have x squared minus 3x minus 4, and 0 divided by -1 is 0. So this is an equivalent equation to this one. They have the same solution. Okay. Now I can factor. Okay. This factors into x plus 1 times x minus 4. We have a product of two factors. One of them has to equal 0. We have a product of two factors that equal 0. So one of them has to equal 0. So either x plus 1 is equal to 0, or x minus 4 is equal to 0. So we have x is equal to -1. We have x is equal to 4. So x equals -1, or the point -1, 0, is one x-intercept, and the other x-intercept is at x equals 4, or the point 40. Those are the x-intercepts. The graph of the parabola crosses the x-axis. Okay. So do we have enough information to graph this thing? I think we do. So we've got to draw a coordinate plane. X and Y axis, okay? And we know that the vertex is at 3 halves, comma, 25/4. So 3 halves is like 1.5, and 25/4 is like 6 1/4. So here's the location of the vertex in the coordinate plane. We already know that the graph's going to open down. It's the first thing I asked. Where's the y-intercept? +4, right? So here's roughly +4 on the y-axis, so it's going to cross the y-axis right here. And it's going to be symmetric. Remember, x equals 3 halves. The vertical x equals 3 is the axis symmetry. So that can be difficult to get just right. So roughly here is where the axis symmetry. Here's the point on the other side of the axis of symmetry. And then we know where it crosses the x-axis, right? It crosses the x-axis at -1, and it crosses the x-axis at, what is it? -1 and 4. So it's going to cross here at x equals -1, here at x equals 4. And that's not perfectly drawn, but based on the vertex, the y-intercept, and the x-intercepts, we can get a crude sketch of the graph, right? That's what we got. Okay? All right, the domain. What's the domain for this quadratic function? All real numbers. The domain for all quadratic functions is all real numbers. The range, right? So remember, domain is all the x coordinates in the graph. And so for every value of x, there's a point on the graph with that x coordinate. But the range is the y coordinates. What's the maximum y coordinate? 25/4. Is there a minimum y coordinate? No. Okay. So the range goes from -infinity, because there's no minimum y coordinate, up to the maximum y coordinate, which is 25/4. And it includes 25/4. This is a continuous function. So y less than or equal to 25/4 is the range in inequality notation. All right. What are we missing? Where's it increasing and decreasing? So where the function's increasing, you're going uphill. Remember, we read a graph from left to right, mathematics. So if this is a hill, and I start walking it from here, I'm walking uphill, right? From way down, from at minus infinity, and then I get to the top of the hill at x equals 3/2, right? So I'm walking uphill over the interval from minus infinity to 3/2. And so in inequality notation, that's x less than or equal to 3/2. Okay? Where is it decreasing? That's where I'm walking downhill. So I'm walking downhill, right? I'm starting here at the top of the hill, and I'm walking downhill to the right. So I started at x equals 3/2, and since there's no maximum value of x, I walk downhill from x equals 3/2 to infinity. So it's decreasing from 3/2 to infinity, which is x greater than or equal to 3/2. Okay? Are you with me on that? So increasing is where you're walking uphill, decreasing is where you're walking downhill. Okay. Right. Any questions? All right, let's do a couple word problems. In example 7, from the top of the building, 160 feet high, a ball was thrown upward with an initial velocity of 164 feet per second. So the position of the ball as a function of time, right, this is the height of the ball, s, as a function of time t. S is equal to minus 16t squared plus 64t plus 160. When did it reach its maximum height? So the number in front of the t squared is negative. So this is the equation of a parabola that opens downward. So let's take a couple observations, okay? T on the right-hand side is the independent variable, right? So time is the independent variable, and S is the dependent variable, and S represents height. So our ordered pairs are time, comma, height, which is T, comma, S in this case, right? We're not using X and Y. We're using T and S in their place. T is the independent variable, S is the dependent variable. All right, so maybe to give you a visual, try to anyway. Here's T and here's S that take the place of X and Y. And we have a building that is 160 feet tall that I'm going to put right on the S-axis, the vertical axis. Okay? So the height to the top of this building, right, is that S equals 160, right? That's the y-intercept. And so then a ball, okay, is thrown upwards, and then due to gravity, right, it eventually stops going up, and then it falls down to the ground. Okay? So this equation, S is equal to minus 16t squared plus 64t plus 160 makes sense because time starts at t equals 0, right? Time starts at t equals 0. And when you put in 0 in for t, you get the height of the ball is what? 160. So when the ball is first released, being thrown up in the air, the ball's 160 feet above the ground, just due to being on top of the building. Yes, ma'am.
Where did the 16 come from?
The what?
The 16.
I'm blind.
Negative 16 t squared.
But they talked about it up here.
Uh,
Okay, they talked about it up here.
so is that
So
always going to be 16?
unless they, I can't say it'll always be 16. Okay, but they talked about this equation up here, right, with the acceleration due to gravity is either minus 32 feet per second squared or minus 9.8 meters per second squared. And from that, they get this equation. Okay, but it has an initial height of 160. You don't have to worry about where the 16 came from. Okay, you just have to worry about the equation. Okay. All right. So then, when did it reach its maximum height? So this is negative in front of the t squared. All right. So you know the graph is a parabola, and so for some value of t, it reaches a maximum height. Right? The ball gets thrown up in the air, and it goes up in the air until gravity causes it to stop going up, and that's when it reaches its maximum height. Okay? So, we got to find the vertex. Right? The vertex, you got to find the value of t and the value of x for the vertex. The value of t tells you how long it takes for it to get to its maximum height, and the value of s tells you what that maximum height is. So again, you can find the vertex for this quadratic function either by completing the square or doing what we did on page 1 of the notes. Okay? And you will notice for this equation, for this quadratic function, a is equal to negative 16, b is equal to 64, and c is equal to 160. So for the vertex, the t coordinate is negative b over 2a. Well, b is 64, so we have minus 64. 2a is 2 times negative 16. Minus 64 divided by 2 times minus 16 is minus 32, which is equal to 2. Okay? So t equals 2 seconds is how long it took for the ball to reach its maximum height, to reach the vertex of this quadratic equation. Okay? T is time, S is height. In part B, what was its maximum height? Well, to find its maximum height, we just put in 2 in for t in the height equation, in the height function. And we have S, so this is A, B is the value of S at t equals 2. So we have S is equal to minus 16 times 2 squared plus 64 times 2 plus 160. And now when I do that arithmetic, I get S, the height, is 224 feet. So 2 seconds after the ball is thrown up in the air, it reaches its maximum height of 224 feet. When will the ball reach the ground? Well, how high above the ground is the ball when it's on the ground? When it reaches the ground? It's 0 feet above the ground when it's on the ground, right? So we set S equal to 0 and solve for T. Right, this is part C. So how long does it take until the ball reaches the ground, right, hits the ground? So I set the right-hand side equal to 0. The minus 16t squared plus 64t plus 160 is equal to 0. Now, to save yourself some misery, you should recognize that each of those 3 terms, or each of those 3 coefficients, are divisible by 16. So you can either factor, oops, this should be squared, I'm sorry. So you can either factor out a minus 16 or divide both sides by minus 16. I decided I'm going to divide all sides, I'm going to divide by minus 16. And why am I dividing by minus 16? So I want to get rid of that negative in front of the t squared so I can factor. Negative 16 over negative 16 is 1. So I'm left with t squared. 64 divided by minus 16 is negative 4. And 160 divided by negative 16 is minus 10. And now all of a sudden, I got a quadratic equation in one variable that I can factor. Left-hand side factors into, it doesn't factor. A is equal to 1 in this case. B is equal to negative 4. C is equal to negative 10. But this is easier to work with with the quadratic formula. These coefficients are easy to work with than those big numbers. And so T, using the quadratic formula, is equal to negative B is equal to negative of negative 4. Plus or minus the square root of minus 4 squared minus 4 times A, which is 1, times C, which is minus 10. All divided by 2 times A, which is 2 times 1. Well, negative 4 is plus 4. And then under the radical, okay, minus 4 squared is 16. Now let's just write it out. And then minus 4 times 1 times minus 10 is plus 40. 16 plus 40 is 56. So, remember, division does not undo addition and subtraction. So we have 4 over 2 plus or minus. Square root of 56, does that reduce? Is it 2 root 14? It is. It is 2 root 14. That's very good. Two root 14. And so t is equal to 2 plus or minus the square root of 14. Now, we got two values of t. Only one of them makes sense. Which one makes sense? If t is equal to 2 plus the square root of 14 seconds, and t equals 2 minus the square root of 14 seconds. 2 minus square root is actually negative. And time has to be positive, right? T equals 0 is when you throw the ball up in the air. Okay? So this doesn't work. The only one that works is 2 plus the square root of 14. And using your calculator, 2 decimal places, 5.74 seconds. Can't have negative time. So it takes 5.74 seconds for the ball, once it's released, thrown up in the air, to reach the ground. Okay. All right, example 8, we'll do first thing on Wednesday, but all the word problems on the WebAssign homework are like the one we just did. There are none like example 8 on the WebAssign homework. So you got everything you need to successfully complete this homework assignment. Okay? I'll see you Wednesday.